matter around us pure? Pure substances and mixtures. When you buy foodstuffs like milk, ghee and sugar from the market, you would have noticed the word pure written on their packets. What does pure mean in these cases? It means having no adulteration. But are they actually pure? In science, when we say that something is pure, it means that the substance is made up of same particles throughout. Milk is made of water, fat and proteins. Hence, it is a mixture and not pure. On the other hand, sugar is made of sugar particles only. Hence, it is a pure substance. Thus, matter around us comprises of two types of substances, pure substances and mixtures. Most of the substances around us exist as mixtures of two or more substances. Wood is made up of cellulose and lignin. Soil is made up of rock, sand, clay, humus, etc. Milk is made up of water, fat, proteins, etc. Salt solution is made up of salt and water. There are also some substances which exist as single substances. They are called pure substances. A pure substance consists of only one type of atoms or molecules. For example, nitrogen is made up of atoms of nitrogen. Sodium is made up of atoms of sodium. Common salt or sodium chloride is made up of only molecules of sodium chloride. On the basis of their chemical composition, pure substances are divided into elements and compounds. Here, nitrogen and sodium are elements, but common salt is a compound. Sugar and mercury are pure substances. What does sugar and mercury contain? Sugar molecules contain atoms of carbon, hydrogen and oxygen. Mercury is made up of only atoms of mercury. So, sugar is a compound, but mercury is an element.
Let's do a quick check.
Pure substance or mixture? Bromine is an element, so it is a pure substance. Sugar solution, mixture रहेगा ना, sugar and water का mixture. Soil वह सब्सटेंस अगर उसमें कुछ इम्प्योरिटी ना हो तो, ठीक है।
Mixtures. A mixture contains more than one substance mixed in any proportion. Milk, soil, lemon juice are examples of mixtures. Let us perform an activity to understand more about mixtures. Take a dish. Put some iron fillings and sulfur powder into the dish. Mix them properly. Hold a magnet over this mixture. What do you observe? The iron fillings cling to the magnet while sulfur powder remains in the dish. The properties of iron and sulfur are retained in the mixture. We use a simple physical process like holding a magnet to separate the iron from the mixture. Now, we can summarize the properties of a mixture. In a mixture, two or more elements or compounds are not chemically combined together. The constituents of the mixture retain their original properties.
देखो आगे क्या बोला था कि मिक्सचर जब हम दो चीजों को एक दूसरे के साथ मिक्स करते हैं, ठीक है, तब वो एक दूसरे की प्रॉपर्टी के ऊपर कुछ इफेक्ट नहीं होता। हमने जैसे कि अभी देखा सल्फर पाउडर और आयरन फिलिंग्स को मिक्स किया, ठीक है, सिर्फ वो मिक्स हो गए, दोनों की प्रॉपर्टी में कुछ चेंज नहीं आए, ठीक है। The constituent of a mixture retain their original properties. मतलब कि जो भी constituents को हमने मिक्सचर में मिलाया है वो constituents अपनी प्रॉपर्टी है वो रिटेन करता है, मतलब कि वैसी ही रखता है। जैसे कि आपने देखा आयरन फिलिंग्स और सल्फर का मिक्सचर था, मैग्नेट पास में ले गए तो आयरन फिलिंग सारे मैग्नेट से चिपक के बाहर निकल गए, सल्फर पाउडर डिश में ऐसे ही रहेगा, ठीक है। तो जो आयरन पाउडर की जो प्रॉपर्टी थी कि वो मैग्नेट को अट्रैक्ट करता है, वो प्रॉपर्टी उसकी वैसी है, ठीक है। और सल्फर पाउडर है वो मैग्नेट से अट्रैक्ट नहीं होता, तो वो डिश में ऐसे ही पड़ा रहा, ठीक है। तो जो कंपोनेंट्स को हम कंस्टिट्यूएंट्स को मिक्सचर में मिक्स करते हैं वो अपनी प्रॉपर्टीज में कोई चेंज नहीं करते, ठीक है।
The constituents of a mixture can be separated by using a physical process like hand picking, filtration, holding a magnet, etc.
ठीक है, मिक्सचर में जो भी कंस्टिट्यूएंट मिक्स है उसे हम फिजिकल मेथड से क्या कर सकते हैं, सेपरेट कर सकते हैं। जैसे कि हैंड पिकिंग, मम्मी जैसे गेहूं में से कपड़ा निकालती है ना, ठीक है, उसे बोलते हैं हैंड पिकिंग। फिर यहाँ पे बोला है दूसरा फिल्ट्रेशन, मिट्टी वाला पानी हो तो उसे फिल्टर करके मिट्टी अलग निकल जाती है कि नहीं, ठीक है। फिर है होल्डिंग अ मैग्नेट, जो भी देखा, ठीक है। वैसे तो बहुत सारी प्रोसेस है फिजिकल प्रोसेस, ठीक है, कि जिसमें आपको कोई केमिकल रिएक्शन नहीं करनी पड़ी, ठीक है। उससे आप कंस्टिट्यूएंट्स को क्या कर सकते हो, सेपरेट कर सकते हो। तो मिक्सचर को हम फिजिकल मेथड से उसके कंस्टिट्यूएंट्स को हम सेपरेट कर सकते हैं।
Here are a few more examples of mixtures. Alloys. Alloys are prepared by fusing together two or more metals or a metal and a non-metal. The components of an alloy cannot be separated by using physical methods. But still, alloys are considered as mixtures because the constituents can have variable composition. They show the properties of its constituents. Brass is considered a mixture because it shows the properties of its constituents, copper and zinc, and the constituents can have variable composition. The amount of zinc in brass is approximately 30% and that of copper is approximately 70%. Alloying is done to improve the properties of a metal. Stainless steel is an alloy of iron, carbon, chromium and nickel. Carbon gives hardness to the mixture, while chromium and nickel give a silvery look to the mixture. Air. Air is a mixture of various gases like oxygen, nitrogen, carbon dioxide, argon, water vapor, etc. Air shows the properties of all the gases present in it. For example, oxygen supports combustion and air also supports combustion. If air is prepared by mixing the required proportions of oxygen, nitrogen, carbon dioxide, water vapor, etc., no chemical reaction takes place. Air has a variable composition. For example, the air in an industrial area will have a higher percentage of carbon dioxide and other polluting gases compared to the air in the countryside. Types of mixtures. Activity. Let us perform an activity to know about the different types of mixtures. Let us make 3 groups of 2 students each, knowing them as Group A, Group B and Group C. Each of these groups has to perform a small experiment. We shall give half a spoon of potassium permanganate and 100 milliliters of water to Group A. Half a teaspoon of potassium permanganate and half a teaspoon of salt to Group B. And half a teaspoon of soil and 100 milliliters of water to Group C. Now, instruct all the groups to mix the given substances using a glass rod. We now have 3 mixtures. Let us now record the observations of each of these groups. Have all the 3 groups obtained uniform mixtures? Which group has obtained a uniform mixture? Group A has a mixture of potassium permanganate and water. This is a uniform mixture. We can see that the particles of potassium permanganate dissolve uniformly in water to form a purple-colored solution. Which group has obtained a non-uniform mixture? Group B has a mixture of potassium permanganate and salt. Group C has a mixture of soil and water. In both these mixtures, the constituents do not mix uniformly with each other. Hence, we can say that Group B and Group C have obtained non-uniform mixtures. Mixtures are of 2 types: homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures. Mixtures in which the substances are completely mixed together uniformly and cannot be distinguished from each other are called homogeneous mixtures. A homogeneous mixture has uniform composition throughout its mass. All homogeneous mixtures are solutions. A sugar solution is a homogeneous mixture because all the parts of the mixture have the same sugar-water composition and have equal sweetness. Potassium permanganate solution, salt solution, seawater, soft drinks, alcohol and water mixture, air and alloys are examples of homogeneous mixtures. Heterogeneous mixtures. Mixtures in which the substances remain separate and one substance is spread throughout the other substance as small particles or droplets are called heterogeneous mixtures. Heterogeneous mixtures does not have a uniform composition throughout its mass. A mixture of sand and water, chalk powder and water, oil and water, milk, ink, soil, paint are all examples of heterogeneous mixtures. Heterogeneous mixtures. Let us perform an activity to understand more about different types of homogeneous and heterogeneous mixtures. Make 3 groups of 2 students each. Name them as Group L, Group P and Group D. Distribute different samples to each group. Give half a teaspoon of potassium permanganate to Group L. Give some chalk powder or some wheat powder to Group P and a few drops of ink to Group D. Instruct all the groups to add the given sample in beakers containing water and stir them properly using glass rod. Now, direct a beam of light from a torch through the beakers containing the mixtures. Is the path of beam of light visible through all the beakers? The beam of light is only visible through the beaker containing drops of ink and water and the beaker containing a mixture of chalk powder and water. Leave the mixtures undisturbed for a few minutes. Arrange 3 filtration assemblies using conical flasks and ordinary filter papers. Now, filter each of these mixtures through the filter papers. Is there any residue on the filter papers? Group L and D did not get any residue on the filter paper. Group B got a residue of chalk or wheat on the filter paper. The mixture with Group L is called a solution. The mixture with Group B is a suspension, and that with Group D is a colloidal solution. Let's do a quick check.
All solutions are homogeneous mixtures. All mixture of potassium permanganate and water forms a homogeneous mixture or solution. Dash mixture does not have a uniform composition throughout its mass. Heterogeneous. Bhelpuri is an example of a heterogeneous mixture. Ink is a colloidal solution. Wheat powder is an example of a tax that gives residue when filtered. Suspension.
Solutions. A solution is a homogeneous mixture of 2 or more substances. Such a mixture has uniform composition throughout its mass. A salt solution, sugar solution, copper sulfate solution, lemonade, a sweetened drink made from lemon juice or lemon flavor, are examples of solutions. Solutions can be of various types. Solution of a solid in a solid. Alloys are solutions of solids in solids. Brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Solution of a solid in a liquid. Salt and sugar solutions are examples of this type of solution. Solution of a liquid in a liquid. A solution of alcohol in water, a solution of acetic acid in water are both examples of this type of solution. Solution of a gas in a liquid. Soda water is a solution of carbon dioxide in water. Oxygen or any gas dissolved in water is a gas in liquid type of solution. Solution of gas in gas. Air is a mixture of gases like oxygen, nitrogen, carbon dioxide, water vapor, etc. Solution of gas in solid. Rubber and sponge are examples of a gas in solid type of solution. Solution of a liquid in a solid. Amalgam is a solution of mercury with any metal, for example, gold. What are the properties of a solution? The particles of a solution cannot be seen even through a microscope. The particles can pass through the filter paper. So, a solution cannot be separated by filtration. Solutions are very stable, that is, the particles in a solution do not separate out on heating. A solution cannot scatter light as the particles of a solution are so small that they cannot reflect light. A solution is made up of two components, a solute and a solvent. The substance which is dissolved in a liquid to make a solution is called as solute, and the liquid in which the solute is dissolved is known as solvent. Usually, the solute is the substance that is present in lesser amounts in a solution, and the solvent is the substance present in larger amounts in a solution. In a solution of potassium permanganate, the solute is potassium permanganate and the solvent is water. Concentration of a solution. The properties of a solution depend upon the nature of the solute and the solvent, and also upon the proportion of the concentration of the solution is the amount if the solution is prepared by dissolving if 50. Let's do a quick check.
Bronze is an example of solution of bronze. कौन से मेटल में से बनता है? कॉपर है टीन. Solid in solid, yes. Tincture iodine is an example of a solution of solid in liquid. Vinegar is an example of a solution of liquid in liquid. Carbonated drinks are example of a solution of gas in liquid.
Let's do a quick check.